हेलो स्टूडेंट्स, आज की वीडियो में हम पढ़ेंगे आइसोमेरिज्म का पार्ट 2, जिसमें आता है स्टेरियो आइसोमेरिज्म एंड स्टेरियो आइसोमेरिज्म की क्लासिफिकेशन, दैट इज ज्योमेट्रिकल आइसोमेरिज्म, ऑप्टिकल आइसोमेरिज्म एंड कन्फॉर्मेशंस. Their definitions, explanation with some example. And I request to the student, those are watching my channel, please like it, share it to the needy student and subscribe it, ताकि मैं और वीडियोस आपके लिए अपलोड कर सकूं. Now, isomers. The molecule with same molecular formula and different structures. We already studied in part 1 about the isomerism, the phenomena, isomerism, and during that phenomena, whatever the structures are formed that are considered as an isomers. Okay, so we already studied all these things. Now we just we again revise it. What is meant by isomers? The molecule with same molecular formula and different structures are called as an isomerism. That phenomena is isomerism. The structures are formed that are called as an isomers. They are the isomers of each other. Now just we'll see about, consider about this one example it is given here, that is a bromobutane. Okay, in bromobutane it forms a four different structures. Okay, by doing the different arrangement of the atoms in their chain. In first structures, we got one bromobutane where Br is attached to a first carbon, and in second structure, that Br is shifted and it comes on occupy on second position of the carbon. Then that is called then 2-bromobutane. So we got a 2-bromobutane. That is the another structure. In both the structures, molecular formula is same, but structural formula is different because CR4, HR 6, 7, 8, 9, and one Br is replaced from butane. One hydrogen is replaced, and in that place, one Br is entered in particular structure. So we got a bromobutane. Now, in see the structure of third, here also the position of CH3 in place of Br, position of CH3 is changed. It is shifted and it comes on occupy on second position of the carbon. Br is remains same as it is in first carbon. Now see, we got another different type of structural arrangement. One bromo to methyl propane. The name of this compound. Here also the molecular formula is same. Structural formula is different. Okay, and at last in four structures Br and methyl group. Okay, in first structure Br is shifted, in second structure methyl group is shifted, in fourth structure now both the some substituents, that is CH3 and Br are shifted and is attached to a second carbon, because at this point, that the point of intersection is also having the one carbon. Okay, so यहाँ पर भी one carbon is there. So here this one is carbon, this one is carbon, this one is carbon. So this is the substituent and this is the substituent. So what is the name of this compound? 2-bromo 2-methyl propane, because 1 2 3 propane ring is there, propane chain is there, and these two are the substituents which is attached as second carbon. That's why the name of this compound is 2-bromo 2-methyl propane. So here, if the molecular formula is same in all the structure, what is that molecular formula? That is the C4H9 and Br. That is the molecular formula, and it shows a four possible different structure. So these are called as an isomers, and this phenomena is called as an isomerism. Okay. Now stereoisomers, the molecule with the same structural formula and different arrangement of atoms in 3D space are called as in stereoisomers. Okay. Now here one example we are given, that is butene, 2-butene. Now here in butene we got a two different arrangement where both the CH3 group, which is attached to a multiple bonded carbon atom, they attached on one side of the multiple bond. Then we got a cis isomers, and if they are present exactly opposite sides of the opposite to the multiple bonded carbon atom, then they are considered as trans isomers. So we got a two different arrangement of atoms or group of atoms in a 3D space. Okay, so these are called as stereoisomers. Now, stereo classification of stereoisomerism. Stereoisomerism is classified into three categories: optical isomerism, geometrical isomerism, and conformations. Now, optical isomers, enantiomers, non-superimposable mirror images of one another that rotate plane polarized light in opposite direction. Okay, that phenomena is called as an optical isomerism, where where the mirror images, non-super mirror images are formed, and they rotate the plane polarized light in opposite direction. But before knowing all this phenomena, we must know what is the mean of non-super impossible mirror images, at what situation they are formed, how they are formed also, and what is mean by plane polarized light. Now we're going to study. Now, non-super impossible. What is meant by non-super impossible? Now, the molecules cannot be overlaid on top of each other. Okay. Now, here some pictures are given. That is the left hand and right hand also. Just we take a left hand and just try to place above the right hand. So, will all the fingers will match if we without turning the hand. If we try to place it, just take one hand like this, and this is another hand. Okay, and just place this hand on the top of this hand. Will they match? No, they will. All the fingers will not match. So molecules cannot be overlaid on top of each other. So that is a non-super impossible images. Now here, one molecule are given, and its mirror image is also given. Now, in first structures, four different circles, that is, four different atoms are attached to a central carbon atom, are given here. Now, suppose we can say, and all these are different. Okay, no one will match to anyone. So, if such type of carbons are present where all the four valencies occupied by different atoms or group of atom, then that carbon are considered as an chiral carbon atom, and the whole molecule are considered as an chiral molecule. Okay, so chiral carbon atom is present in that molecule. Now see the mirrors images of this one, first structures. So if we try it to overlay it on second molecule, will it match all the position of the atoms on previous one atom? No, it will not match. Means molecule cannot be overlaid on top of each other. Okay, so that type of images are called as a non-superimposable mirror images. They are the mirror images, but non-superimposable because they are not, molecules cannot be overlaid on top of each other. All the molecules will not match if we try to consider one molecule and try to place on above the second molecule, then that molecules will not match. Okay, so that is called the non-superimposable mirror images. Now, plane polarized light is the light in which vibrations of electric field occur only in one plane perpendicular to the direction of propagation. That is a plane polarized light. Now, see here one diagram is given. In this diagram, normal source is given. This is the normal source. Okay. It is having a vibrations. Those are vibrate in all directions, in different directions. Okay. It is vibrate in all different directions. Now, after passing that radiation through the polarizer, this is the polarizer. Here, this one is a polarizer. Now, after passing the radiation through the polarizer, we will get a light which vibrate only in one plane, single means this is also having one plane, this radiations is also having one plane, this radiation will also having one plane, this radiations is also having one plane, means all the radiations are vibrate only in one plane, and such type of light is called as an plane polarized light. So their vibrations are restricted only in one plane, and here normal source having the radiations, those are vibrate in all directions. That is the difference between normal source and plane polarized light. Now, enantiomers are the pair of molecules that are the mirror images of each other but cannot be superimposed. Okay, so that is called as an enantiomers. Now, enantiomers show some property for plane polarized light. It rotates the plane polarized light in clockwise and anti-clockwise direction. Okay. Now, here two pictures are given. Normal source having vibrations which rotate in all direction. After passing through their radiations through the polarizer, we got here plane polarized light whose vibrations are vibrate only in one plane. That is a plane polarized light. That now after getting that plane polarized light pass through the enantiomers, which rotate. Here, sample A of enantiomers are taken, which rotate the plane polarized light in clockwise, and in downwards, one picture is given, which rotate the plane polarized light in anti-clockwise direction. These enantiomers are the mirror image, are the pair of mirror images which cannot superimposed on each other. Means what? They must have in their structure one asymmetric carbon atom, that is a chiral carbon atom in their structure. That's why their mirror image are not superimposed. What is meant by chirality? Now we'll see the chirality also. Now stereoisomerism. Stereoisomerism is a type of isomerism in which the compounds having same molecular formula, same bonding between the atoms in their structure, but three-dimensional arrangement of atom is different in their structure. So we will get the stereoisomerism. Again, it is classified into three categories: optical isomerism, geometrical isomerism, and conformation. Now, geometrical isomerism, which occurs due to a different possible position of atoms or group of atoms around a multiple bond in space. Okay, so here you can observe we are taken one example, that is a butene, two butene, which show a two different arrangement. They form a two different isomers. One is in cis isomer, second is in trans. In cis isomers, you can easily observe that CH3 groups are on same side of a multiple bonded carbon, and in trans isomers same group of atoms are on opposite of the multiple bonded carbon atom. Okay, so in this case we got a trans isomers. Conformations are the infinite rapidly interconverting special arrangement of atoms in a molecule resulting from rotation around carbon means single bond, and also known as conformers or rotamers. Whatever the isomers, after rotating the single bond, we will get a different arrangement. That arrangement of molecule that are called as conformers or rotamers. And these 3D shapes do not involve bond breaking, but making them distinct from configuration. It includes the staggered conformation, eclipse conformation, and stability is often analyzed based on their steric strain. ओके स्टूडेंट्स, आज का वीडियो हम यहीं पे रोकते हैं, और मैं आशा करती हूँ मेरा वीडियो सबको समझ में आ रहा होगा. एंड अगेन आई रिक्वेस्ट टू एवरीवन दोज आर वाचिंग माय चैनल, लाइक माय चैनल, सब्सक्राइब इट एंड शेयर टू नीडी स्टूडेंट्स. और सब्सक्राइब करना मत भूलिए. थैंक यू.